Let's discuss two different types of reactions. First we have endothermic, then we have exothermic. Endothermic reactions absorb heat from their surroundings. Whereas exothermic give off heat. So these definitions sound really simple, but when you're talking about specific reactions, it can be a little bit more complicated. So when you're talking about specific reactions, what's helpful is to first describe the system. So if we're talking about ice melting in a jar, are we talking about just the ice in the jar, or do we need to consider the surrounding atmosphere and different things in the atmosphere? Do we need to talk about the room? Do we need to talk about the building? Do we need to talk about outside? How big is our system? So first we need to define the system. Then second, we need to understand that the conservation of energy. And the conservation of energy just means that energy cannot be created or destroyed. So when you add energy to a system, it's getting absorbed, and when you give off energy or heat, then it is going into the surrounding atmosphere or just the general surroundings. So it's just transferring between objects or different solutions or fluids, but it's not being created or destroyed. It's also important to know for the conservation of energy that everything is always trying to get to the same temperature. So want the same temperature. And the energy or the heat always flows from hot to cold. So if a substance is what we consider to be very hot, has a lot of energy, it wants to give that energy off to the cold part so that they wind up being equal. And then the third thing to remember is that phase changes need energy. So if we are going from a liquid, or from a solid to a liquid, we have to give the system energy. And same thing if we're going from a liquid to a gas, we have to add energy into the system. Remember, we have our graph that looks like this, and we have energy versus time. So as the time increases, our energy or our heat is not increasing, or the energy is being absorbed by the system, rather. So let's talk about an example. Say we have ice cubes in a cup of water. You guys are very familiar with that. So, and we apply heat. So what happens? Well, the ice melts. Is this endothermic or exothermic? Well, it's endothermic because the system, the ice and the water, are absorbing the heat. And what temperature is the ice? Well, the ice is 32 degrees Fahrenheit. What temperature is water formed from right when the ice begins to melt? Well, the water begins forming at 32 degrees. Remember our heating curve still. This value here is at 32 degrees. So during this time, the temperature is remaining the same, even though energy is being added to the system. All the energy is going from making ice cubes turn into ice. So we have to remember that it takes energy to convert the ice to water. So at the instant the ice melts and water forms, they're both 32 degrees, and the heat energy is used by the ice to change it into water. So the key to understanding endothermic and exothermic reactions is knowing that endothermic reactions absorb heat from the surroundings. If you can say yes, it absorbs heat from its surroundings, then it's an endothermic reaction. If you say no, then that means that it's exothermic, that it is giving off heat. So your homework is to think about a natural occurrence of an exothermic and an endothermic reaction. So you should come to class with two things written down. What's an example of an exothermic reaction that you come into contact with all the time? And what's an example of an endothermic reaction that you come into contact with all the time? But you cannot use this example here with ice melting.